Hello everyone, let's talk about another medium problem on Leetcode today. Score after flipping matrix, Leetcode 861. It states that given m into n matrix grid, uh, we have to return the highest possible score after making any number of moves. So number of moves does not matter, but we have to calculate the score, and let's see how we can calculate that score. A move consists of choosing any row or column and toggling each value in that row or column, right? And changing it. So we are just toggling um, 0 to 1 and 1 to 0. So that's and why will we do that? So every row of the matrix is interpreted as a binary number, and the score of that matrix is a sum of these numbers. So for example, this is the first binary number we can see, right? So this is the input matrix, all containing 0 and 1s. Then in the first step we flip like the first row, so we get 1 1 0 0, right? Then in the in the second step we flip what you say second column. I mean, if we consider the zeroth index, column at the second index, and we flip 0 1 0 to 1 0 1, and then eventually as a last step we get like uh, what do you say, we flip all the zeros in the last column and replace it with 1, right? So whatever we do, so the idea is that we flip all the ones to 0 or zeros to 1 in a row or a column, so that's considered as a move. And whatever number we make, so for the first row we make 0 be 1 1 1 1, so that is 15. Then we make 1 0 0 1 as a second what do you say value, it is 9, and then again 15 for the last row, so we get 39 as an answer. So we have to add the rows represented as binary numbers in such a way that we get the maximum value or maximum sum out of those rows, basically. So we have to maximize those rows, and based on that rows we have to calculate the binary numbers and convert it to the sum and return that sum. So now let's jump into the solution space. I hope the problem was clear. So one way we have to look at it is like it's a greedy problem, and not like some dynamic programming or some other problem. And greedy approach tries to maximize or minimize something. So when we look at this matrix, what is the bare minimum thing that the number should be more, right? So first thing is like if I have this, let's see, like if I have the row like this 0 0 1 or 1 0 0, right? Which one will be more with the same number of bits set? This one or this one? Of course, this one, because one is MSP here, and in this case, it's the least significant bit. Similarly, it will be more than 0 1 0 as well, right? Because this is the highest position one can be. So first thing we need in this problem is that one should be the first number, no matter what in the row. So we should flip all the ones to zeros in the row, in all the rows, such that we actually get 1 in the start of this number. Second thing we need is like, so once this is in the mind, so we can see that okay, in this case 0th row was starting with 0, so we flipped 1 1 0 0. So far it makes sense. But then after that we have to also flip the columns accordingly. And why will we do that? Because suppose we have all the what you say rows starting with 1, and now some rows have 0 here, some will have 1 0, some will have say 1 1, just staying this out. And now what we have to do is like all the column wise we have to see if our what you say sum of these ones is more than what you say half of the row. So then we don't need to flip anything. The reason is like we already must be getting the higher number when we go from left to right in this binary number, column wise. Why column wise? Because uh, as we go from left to right, our MSP starts to decrease. So for each of the we go from most significant bit to least significant bit. So we have to see all these digits column wise. So if in one column we have more number of ones, right, from left to right, so in this case we just replace 0 with 1. So in this case we don't have to do anything because we count more one, and when we are calculating this number, these ones will significantly add any thing to our will significantly add to our total. Now in this case we see 100, right? So we see that there are two zeros and one, so we can actually use a flip operation that we were talking, the move operation that is provided to us, and we can just say 110 again here, because then we can actually increment our sum. Now that we have understood this, now it boils down to two things. We have to flip all the rows which actually start with 0, right? That is the one thing. So that means we take care of the 0th column of all the rows. And second thing is, for rest of the columns, what we do is like we flip out all the ones to zeros and zeros to one when number of zeros is more than number of ones, or basically when number of ones are less. So we have to just increase those number of ones and our sum will automatically increase. And also I think now let's jump into the code, and we can also talk about one more algorithm. We can also see like another algorithm based on this after we code this one out. um, but I think this is the main gist of this problem. So first thing we need is yeah, we can start looping onto this array. So we can say let m be this and grid 0 dot length. Yeah, so m and r set. Also remember, I think there are constraints, so they always give like what is like minimum m and n they provide. So I can easily do 0. If the programmer says that array can be empty or something, then please check this also out. Otherwise we'll get an index out of bounds error. Then what we can do is like we can just start looping onto this array, right? From row wise, and start seeing the what you say uh, each column one by one. So 0th column one by one. So if grid I 0 is equal to what you say 0, we have to just flip this one out, right? So we can just say flip row, and I can pass the grid here, and I can pass the column here as well, a row there as well, right? So let's define this method. I mean, we can also do it in the same place. I'm doing it separately just to keep the code clean. So basically, when we are running this code, basic thing we need is the same grid and a row index, right? And we can just say for equal to 0, or actually j equal to 0, just to set like in the mind that j is less than grid 0 dot length, or grid r dot length, I mean, just to be, anyways it will not change, but yeah. And if what you say and we will just we don't need to do any if condition or anything, because we have to just flip the row, right? So we will say grid r j is equal zor equal to, oh sorry, zor equal to 0, sorry 1, right? Because what this will do is like if the value if what XOR operator does is like if we already have 1 there, it will we can actually quickly look at the what you say what XOR operator does. So 1 XOR 1 will give us 1, will give us 0, and 1 XOR 0 will give us 1. Similarly 0 XOR 1 will also give us 1. uh, and if it's what you say, and so I think this is what matters, right? So if it's 1 or 0, it will flip it to 0. If it's 0, then it will flip it to 1. So this is the neat technique we can use in the like a bitwise operation basically. And now we have flipped all the rows basically. What we can do is like we have taken care of the zeroth column, right? So now we can start taking care of other columns where we can say, okay, from first column we can just start looping. And now we will create a variable called call sum just to see number of ones. So like if in this case, for example, like this case, column sum will come as 1 because that's the only where value where actually sum is equal to like there's only one in this column. And if it's less than say 3 by 2, in this case 1.5 basically, that means we should flip the column, right? We should basically because number of ones are less than number of zeros, so we will just do this now. Note that row wise loop is inside and column wise is outside, but overall time complexity will still be m into n, but we'll talk about it in a moment. Plus equal to grade ij. Now, once we have calculated all the column sums for that row, we will just check if call sum is less than 2 into, call sum into 2 is less than, what do you say, m. Why m? Because in each column there will be m rows and we are calculating the sum of those. So if it's less than half of it, that means we should flip column now. So which column should we flip? We should flip column J, because we are running it for the jth column. So I can just copy paste this code here to save time. And instead of calling what you say flip column, we can just call flip call and pass in the column and loop it on I equal to 0, I less than grid length I plus plus, and we will just replace I here and column C here, and again do the same thing which we were doing earlier. So now we have flipped all the columns, we have flipped all the what you say values. The last bit, now we have the matrix in this form, the last form that we see it here in this diagram. So now we have to just convert each row into the binary number, right? So now we can just do the loop. We can do a simple loop this time instead of what you say looping it on what you say column. First we can loop it in any direction. So I'll go with the row because we have we have to do it row wise only because we are calculating the number row wise. Uh, so what we need is we can just loop onto the outer loop uh, and then loop onto the inner loop as well, right? And let's also define the answer that we will return. So we will say in sum equal to 0 and sum plus equal to what you say. Yeah, so now for each row we have to what you say return the value. Like if it's a number, we do something with it. If it's not a number, we again do something with it. So what we can do in this case is we can just take grade ij. So if it's a number, if it's 1, in this case what we will do is we will just um, multiply it by what you say. So for example, let's take the example here. So we have let's draw it first. So suppose we have let's just look at the first row in this case. So it's like 1 1 1 1, right? I'm talking about this last matrix that we are seeing. So when we are calculating the sum, so first thing we need is like we need 1 at this index, right? So what will be the value of this one? So value of this one will be uh, 1 into 2 to the power of what do you say 4, right? That is 16 minus 1. That's the idea, right? So that means we have flipped this number 4 times just to get our answer. In this case, sorry, it will be just 1 into 2 to the power of 3, which will be equal to 8. My bad, sorry. Yeah, so it should be equal to 8. Then what will be the value of this one? This one's value will be equal to 4. Then what will be the value of this one? This value will be equal to 2. And finally 1. So this will give us 15, right? That's what we want. So at each value in this row by matrix, so what will be the value of grid ij? It will be uh, what you say 2 to the power of like whatever is the value of j remaining, right? So suppose we have n minus so for what you say for this one, the value will be 2 to the power of n minus 1, right? So it will be 2 to the power of 3. For this one, it will be 2 to the power of n minus 2. Why? Because we just need to take these two values here, 2 to the power of 2, which is equal to 4, right? So basically, we have to do 2 to the power of n minus j minus n minus 1 minus j, right? That's the so at any point in the ith row, if the value of we are at the jth column, and if that value is equal to 1, right? If it's 0, then it will be 0. But if it's 1, it should be equal to 2 to the power of n minus 1 in minus j. I think that's the important thing. If it's 0, we just multiply by 0, so we get 0. Uh, and in Java, for example, one good way to actually get the power of is like either we can use math.power or something. But even cooler thing is like we can use a left bitwise operator, and we can say, okay, it should be equal to, we have to do it n minus 1, for example. For this one, we have to do, for this one, it will be 1 n minus 2, right? So finally for any one in the ith row at jth point, it will be n minus 1 minus j, right? So that's the idea. We will just use this idea to actually now code it. So we will just so it will be just as we talked about. So it will be 1 n minus 1 minus j. And once we calculate these sums, so we are not calculating the sum row wise, right? We are just calculating the in ith row, we are just calculating the value of the bit set at the jth column basically, and that will give us our sum, and then we will just return this sum. And now we can test this code out. Oh, there is some missing return statement somewhere. It should be void. My bad. Hmm. Awesome. So let's submit this code. Awesome. So it's like it takes 0 milliseconds as per Leetcode, but I think now let's jump into the time complexity of it. So if you see, we are doing this flip row operations take O of m into n time, because if grid I 0 is 0, we actually go through m rows first, and then for each row we check whether we have to flip or not. And in the worst case, we may have to flip the rows for all the columns. So it will be flip all the rows. So basically it will take O of m into n time, or m square time in this case. Then this will also take O of what you say m into n time, because again we are going through all the columns. And finally and again once we go through it, we have to again go through all the rows. So it will be O of m plus, sorry, technically this will be O of m into n, and this will be O of n into m, and again this one is O of m into n. So this will again take what do you say, O of m into time, and this is the best we can do because we have to calculate the sum for each of the rows and columns in this approach. So I like this approach because it's simpler and does as the problem describes it. And in terms of space complexity, it just takes O of one time because we don't create any data structure or anything, just to store some intermediate values. So with that in place, let's talk about another solution. Technically we are done, but just I've also added this solution to my blog. So you can also do assume one thing is like, uh, let's draw it out so it's clearer. So suppose what we have is like, suppose we assume that we have the matrix like this, right? So what we can say is like, first thing we assume is like all the values on our zeroth row, sorry, all the values in our zeroth column for all the rows, all the values are 1. So technically what this means is we are assuming that all the like our initial answer is equal to 1, sorry, 2 to the power of, what do you say, uh, n minus 1, right? Which is number of rows minus 1, right? We talked about it. So all these ones will be equal to 8 because it will be 2 to the power of 3. So 2 to the power of n minus 1 into m rows, right? So let's assume our, because this will anyways happen, right? Uh, Without flipping the zeroth row, we will, or sorry, without flipping the zeroth column in all the rows, we have to make sure that all the values should be 1, whether we have to flip or not, but all the values in the all the rows, sorry, all the zeroth column or zeroth value, like these ones in all the rows should be equal to 1. So at least this should be our answer. Now when we start looping onto this array, what we have to make sure is like aij, because we know ai 0 is always 1, right? So if we see aij equal to ai, what do you say, 0, technically it will be equal to 1, right? So we will count this approach, and we will get the column sum like we were getting earlier. So we loop on all the columns, and for each value in the row, in the remaining row, like we start looping from here, and like we see all the, what you say, rows one by one. If they are equal to the initial value, that means we have got 1 and we add it to the sum. Another approach can be that maybe they were not 1, so they may be 0. So we will find out, we will add initial answer that we talked about, and we will add math dot max of sum of ones that we calculated, and what is the another value which can be possible is like m, right? The maximum value for each column where all the values are equal to 1, it will be equal to m. So we will just do m minus sum in this case. So we will calculate the ones here. So sum of all the ones. So suppose it was 3, suppose it was 1, and what is the maximum number of ones we can get, it's m, right? So it will be m, in this case, in our matrix it will be 3, because we have 3 rows minus the sum, so in this case 1. So whichever is the maximum of 2, because in that case we are assuming we are flipping the operation of flipping the columns, flipping the values in the columns. And once this is done, I think we are actually done, and we will start adding the uh, and for that value, whatever we got as an answer, we will just what do you say, flip it to the left as well, because this is needed as well, because um, suppose we are in this row, so then we have to multiply all these value by 2 to the power of 2, right? Because that's the value of the significant bit at position 2 in this binary number. So if you got this concept, I think, sorry if it was not very clear, but basically you can also do this solution in one pass. So now let's jump into the code here as well. I mean, you can also skip this part because first part is good enough. Like we said, like the time complexity wise, there will be no advantage. So instead of using 3 pass solution, we can just get it in a 1 pass solution. And sometimes programmers or the interviewers actually ask for it. So now let's jump into the code. So initial yeah, code will be same, but now we can just say int answer is equal to what you say 2 to the power of n minus 1 into m. So how will we get 2 to the power of n minus 1? So we will just do a leftwise bit operator like we did earlier, and we will multiply by m rows. So we have taken care of the 0th column in all the rows. So now we will start looping onto the what you say remaining columns. Uh, and let's calculate the current sum. Right, it will be equal to 0 initially. Now what we will do is like we will just say for int I equal to 0. Now we will iterate on the rows, right? So I less than m, I plus plus, and if grid ij is equal to grid I0. We know, like we assume that we have flipped the rows, right? So uh, if the values are flipped, and suppose if AI is, we actually technically we have not flipped it, that's the important part. But suppose if this was 1 and suppose this was 0, like in this case, so we are assuming that this is 1. So even if we see this as 0, we assume that actually we have flipped it. And the reason is if AI 0 was say AI 0 was 0, then AIG will be flipped, right? And so it will anyways we would have increment we would have done the flip operation for all the row, right? So if this was 0, we also made, if this we made this one, so that this also automatically became 1. So that's how if this value was 0, we don't have to worry about. If this was 1, we don't have to worry about again, because if this was 1 and this is 0, they will not be the same. So what I'm trying to say is like whatever is the value in the 0th column, it should always match the value in the remaining columns of that row. Because if we do the flip operation, if it was 0, it will always say the same, right? If it was 0, it will become 1, and then all the other values which were 0 in that same row will also become 1. So that's the idea that we are targeting here. So we will just say column sum plus plus. And now the interesting part, we will just do answer. We will add it to the answer now. So the idea is again do the 2 to the power of n minus 1 minus j, because now we are in the remaining what you say columns. And once we do this, now the next thing is we will just multiply it by the number of column sum we have seen. So either it can be column sum, or it can be m minus column sum, right? And once this is done, we come out of the loop, and this will and this should be our answer. Now let's run this code. Hopefully there are no compilation issues. Oh, there is one. Mat.max of either of them. So yeah, cool. This submit. Let's submit the code. It's taking a bit of a time, but let's see what's the time complexity. Again, it's the same. So like we talked, it's just O of m into n. Only difference is like it's just a 1 pass solution, and the previous solution we saw was 3 pass solution. I hope you like the video. Sorry for such a long video. I tried to keep it again short. But I think this was an interesting problem, and I wanted to share the bitwise manipulation that we were doing. If it helps you, please like and subscribe. Have a nice time.